Right, it looks like we're at time at 12:25. Hi everyone, welcome to today's session. My name is Salma. I am the CEO and co-founder of Remyx AI. It's a pleasure to talk to you all today about this topic. It's super near and dear to my heart. Today we're going to talk about optimizing foundation models for your application. So excited to walk through. Before we actually dive into the content, I do want to route you to the chat right now. I left a couple links for you to use. So we have a shareable for this whole deck. It has a lot of goodies in it, so I'd recommend copying that and saving that for later, or you can follow along with me as we go. Also, make sure to connect with me on LinkedIn. I'm excited to chat with more practitioners. And also, you can find us on Twitter. So plenty of areas for us to chat and collaborate with on the future. Alrighty. Also, if you have any questions, please add them in the chat. Unfortunately, I won't be able to see them very easily right now, so we might have to wait until the end of the session to get to them. But I'll try to check back and see if I can incorporate answers to your questions as we go along. Sounds good. All right, without further ado, let's get into today's content. All right, so brief intro. I already kind of told you a little bit about me, but I'll tell you a little bit about the team. Terry and I have been working together for 10 years. We're both the co-founders of Remyx AI. We're very much machine learning practitioners. We've worked in a variety of industries, including healthcare, robotics, recommender systems, gaming, infrastructure. So we've had a lot of pleasure to be able to get into a variety of problems over the years. And with Remyx, what we're trying to do is we're building an agent-guided MLOps platform. So we want to simplify the set of tools that developers use to then customize machine learning for their applications. All right. If there's anything you take away from this presentation, these are the following tips that I want you to keep in mind. What we want to convey to you is that you can reach state-of-the-art model performance through parameter-efficient fine-tuning. So unlike the previous decade of machine learning development, where you needed plenty of resources such as data, compute, and plenty of teammates to be able to get something off the ground, nowadays with generative AI, it's possible to actually get a model customized to any use case with very little resources. And we're going to dive into that more into the conversation. Along with that, generative AI has also made it easier for us to design data sets. So we're able to use data retrieval and synthesis through generation to make better data sets for training. And then lastly, another very important topic we'll cover is it's getting easier to evaluate models at scale using LLM evaluation. So we're going to dive into all of these details in more detail in just a moment, but keep these top three topics top of mind. All right. Let's dive into design and evaluation. So before we even get into, data processing or picking the right architecture or starting to think about, what model you're going to use or deployment, we want to take a step back and look at the big picture about where we want to end up with. I think that it's easy to kind of dive into maybe picking your favorite, model architecture right out the gate. But there is I think significant gains to be taken when you take a step back and consider all of the constraints that you need to have in mind when you're developing a new machine learning solution. So things that you might have top of mind are what compatible architectures with your deployment target are there available to you. So you might consider evaluating models on portability. How easy are they to deploy on a variety of different hardware targets? So is this a model that's going to require, tons of A100 compute, or can you get away with more consumer-grade GPU resources? That would be awesome. Can you get away with even CPU resources if that's available? That would be something to consider. Another important consideration to take in mind is the speed accuracy trade-offs you'll have to make when you're choosing essentially all the components for your machine learning system. So with speed, you might be able to get models that have more throughput. You could get results faster from them, but you might have to give a little bit in the accuracy because you might have to choose smaller parameter models, for example. And for accuracy, if that's an essential I guess, an essential, I'm totally forgetting. But if accuracy is something that is very important to your system, then you might have to give in some speed trade-offs, or you might have to consider that you need more compute to actually get that model off the ground. And then another consideration that I think other folks maybe don't keep in mind is that when you're choosing an architecture or a model off the model zoo, for example, if you're in Hugging Face and you're looking at all the variety of models that you can choose, you want to choose a model that has great data priors for your use case. And this is an important point. I think that plenty of developers might gravitate towards choosing a model that is very great on all the benchmarks, but you might be overlooking a model that is actually really, really well set up for your specific use case. So for example, if you're working on a healthcare problem, you might want to consider a healthcare variant of a model architecture that you think is performing really well instead of maybe a base Mistral model, for example. So this is something to consider that will set you up in a better position for creating a good model deployment down the way. All right. So model customization calls for custom evals. This is another point that we also want to hone in on. I think there's a lot of options out there right now, and a lot of folks trying to attack the problem of LM evaluation. I think foundational models in particular have this problem where you can't rely on some of the traditional metrics that you might have used for other classical machine learning systems to evaluate how well they're doing. So for example, you don't have accuracy measurements that like you do for an image classifier for an LLM. So we need to think about evaluation in a different way, and we also need to consider methods that are both scalable and flexible for our use case. So essentially, what we have today nowadays, you have the research benchmarks you might find available. There's also other platforms like the chatbot arena where they incorporate human feedback. But these kind of have their caveats in terms of how far you can take them, what mileage you can get out of them, because they're not very specific to what you're building. And I think that is essential to keep in mind through the entire life cycle of the machine learning process. So what we advocate for is to be able to customize your evaluation criteria even from the start using generative AI again. So at Remyx, we actually have a feature called Mix Match. And what Mix Match does is that taking a sample of a prompt of the type of model that you want to go ahead and train. So for example, in the right-hand side, you see that I have a prompt that is kind of representative of a task that I want to train my model for. In this case, I want my model to understand these various tools that I have in that prompt. Which then base model should I start off that has the best priors for example, instruction following, and perhaps maybe instruction following with the coding context in the background. So Mix Match essentially takes that prompt and then tries to predict which base model is actually has the best priors for the task that you're going to ultimately train it for. So in this case, a Mistral 7B Instruct was the better choice out of the variety that we ranked. And evals, obviously, that was an evaluation. If you go back, this is even before you get started training. So evaluation can happen at all points in the life cycle. So if you can continue to go back to your North Star about what the system should look like at the endpoint, then you can make better informed decisions all along the way. That'll essentially reduce the time that you need and experimentation cycles that you need to actually get to a good result. So down the way in evaluations, still thinking about this topic, you can continue using LLMs for then evaluating the end state after training. There's been a research, and I have links in the deck here as well, that show that there's high correlation between LLM evaluators and human evaluators. So what this means is that instead of relying on an army of people asking questions that they're interested in about your system, you can use an LLM to then ask the precise questions that you're looking for to then be able to get to the measurement of performance that you're looking for. And so this is just a more scalable and flexible approach and can be used in all stages of the ML development process. So as we saw, an LLM evaluator was essentially used for mixed match. It could be used in post-training, and then it could also be used while monitoring the model once it's deployed. So something to keep in mind that you'd like to design. I think LLM evaluation just offers for more flexible test design approaches. So in this right-hand side, this is another feature of Remyx. This is called the Remyx Acuity Score. And so we're basing this off of a technique or a set of methods from the Flask paper, which is also linked in this deck. So keep that in mind. Essentially, we were able to design a test about the skills that we wanted our particular LLM to be able to hit, and then how to compare the responses based on these skills with other models. So in this case, we were comparing our train here, which I called my local mentor run 2, with GPT-4. So how does it perform in terms of a scoring mechanism on all of these different kind of qualities about the model? So historically, when folks are still discovering that you are able to replace human evaluators with LLMs, it started with using GPT-4 as the baseline. It was one of the best tools to use. But now we're actually moving into a world where we're getting closer and closer to quality, on par quality with GPT-4, using open source models. And open source models is a better route to go, I think, overall. First, it'll save you time and money in terms of in the long run. You won't have any constraints about how many times can you query GPT-4 in any amount of time. Also, just more cost effective. You can have more control over all the variants of serving that infrastructure, and then also more control about the model asset itself. So this is another area that people overlook. When you have access to the underlying LLM evaluator, in this case, if it's not GPT-4, you don't have access to when they update GPT-4, and that might impose problems in terms of how your LLM evaluator is performing. So having the asset yourself, you're able to version control, and then you're also able to design your test accordingly. So you're able to set up a test that will score your model in a variety of ways. So if we go back to this slide, we're scoring the model here on skills, but maybe in a different kind of test, you could score your model based on how accurate is it on retrieval, or essentially any other task. How accurate is it on making a good instruction response, for example, if it's a specific type of task. And then even going beyond just one model, you can extend to now a jury of models. So then you can design a system that has a variety of voices that are able to look at the response in a variety of perspectives, and then give your evaluation from that as well. So this essentially gives you just more flexibility to understand your model process and development all along the way. All right, so another awesome area where generative AI is making things simpler is through data synthesis and data design. This one I think is a particularly exciting topic for me. So let's start first with a win, actually, on this topic. If you go into Meta AI's blog, where they discuss how they developed Llama 3, if you're familiar with the new Llama 3 release recently, they describe things that worked for them to increase the performance of this new variant and getting closer to GPT-4. And a key part of that was, one, it was using Llama 2 to retrieve better samples for training this new variant. And then it was also using synthetic data to train, so they could round out different kinds of skills like coding, reasoning, and long context. Another particularly interesting clue here is that they also use synthetic data to create longer documents. Keep that in mind, because that's going to be important in a topic later in this talk. But essentially, when you're trying to train a model nowadays too, with some of the techniques that are available, which we'll touch upon soon, is that the highly relevant, high quality data samples trumps volume. So the key here to make a better system, and a better system that also costs less, is to focus on the quality of those data samples and how representative they are about the problem that you're trying to approach, rather than just sheer volume. And then another clue is that long samples actually improve training results. You can get away with less number of samples in your training data, and then essentially filter down your data set to the samples that have the longest responses. And that is shown to help improve baselines for training these models. That's another result that's also linked here. Interesting read. And then you can also, besides just synthesizing data straight up, you can augment an existing data set with real data. So this is where you could also use retrieval mechanisms to then use an LLM, for example, to judge which samples are of highest quality, kind of like the Llama 3 result was using Llama 2 to then use as a judge to retrieve real samples to then make the new data set for Llama 3. So both of these techniques kind of help you get away from having to, process loads and loads of data and just, relying on volume as we did the last 10 years. And now we could just focus on quality and smaller amounts of models of data that are high quality to the task that we're looking to solve. And then on Remyx, we're incorporating the same results into making other tools as well. This one's called the Remyx Data Composer. And what it does is it gives you the ability to synthesize a data set from just a prompt, an example context about what you want the data set to be, or you can also augment an existing data set. So in this example, I'm trying to create a data set about climate change and making a climate specialist. And so from a prompt, I was able to, as you can see here, this was my data source that I gave. And then the service was able to expand into this table of prompt and response, which then I can use to go ahead and train my own, for example, custom chatbot that is an expert in climate change. So this will give me a great starting point for me to go ahead and start making my first model. So in this example, I can download it, and it'll also tie into our in-house training services if you wanted to try that too. All right. So adaptation. And adaptation, we just mean essentially model fine-tuning. I think one of the most exciting results recently, thanks to some of the advancements made by generative AI, comes parameter efficient fine-tuning. So if you look historically on what needed to be done for training models, before pre-trained models existed, essentially before deep learning was around and you had to use classical machine learning methods, you had to use, from scratch, training a model from, a giant data set that you've curated that has the data distribution you're looking for to then train for a task. And then we were able to evolve into being able to piggyback off of a pre-trained model, so a model that has baked in priors, and then essentially just use a smaller data set to perturb it or to change the task. So for example, with image classifiers, we went from being able to detect everything or classify everything in ImageNet to, for example, I just want to make a classifier for my desk versus my chair. And now with foundation models, we have new techniques like LoRa, so low rank adapters, to be able to perturb the model with even less resources. If you're not familiar with LoRa, I would definitely click into that link and learn more. But essentially at a high level, what we're doing is that we are perturbing a very small matrix, and we're adding a very small amount of parameters into the model that then gets merged into the base model. So the idea here is that we can take a really, really minuscule part of a weight matrices that we can then merge back into the model. And the idea is that we can, again, kind of like transfer learning, we can essentially piggyback off of the base weights and just perturb them ever so slightly for the task that we want to run. So for example, if you wanted to make a chatbot that just talks about giving startup advice, you could do so through this technique, and you wouldn't require as much data to do so. So again, benefits of adapting models using LoRa It means that because you need so few resources, so you don't need that much compute to train a full model for all the billions of parameters. You do a very small part of that model that then gets merged in. It's more cost efficient over full fine tuning. It takes less time and less compute. It's faster to train. And then you can just constrain a model that's off the model zoo that maybe is kind of addressing your problem, but constrain it enough to actually perform for your task. So if I just took, for example, my example again about the startup advisor, if I took a base model off the model zoo, like a Llama 3 model, and then asked for advice, it might be able to give me something useful. But if I fine tune it with LoRa, for example, with my own data set, I can, for example, perturb the style of that voice to follow my favorite podcaster who gives startup advice, or constrain it to only talk about startup advice and maybe not something else about that model. So at Remyx, we have our own services to fine tune these models for you if you'd like to use that. But you can also explore this technique on your own with a variety of tools. You could use Hugging Face or any of these other tools. Some tips that we have baked into our platform that you might want to explore in your own experiments. I think these are some of the ones that we found to be highest leverage. First, train all of the target modules. So again, because we are training such a small amount of parameters that we're then injecting into the base model, we want to make sure that we train as many of those, the small percentage as possible. We also, in the parameters that we want to adjust, you want to increase the rank parameter. This gives more capacity to the adapters. So essentially, it just perturbs the model a bit more into what the adapters have been trained to do. And then some other things that you can look into, which we covered earlier, you can establish a great baseline just using 1,000 samples of the longest responses. This is a great place to start. It doesn't really require much data at all that you need to curate, and then you can even synthesize pretty quickly 1,000 samples for any task. And last but not least, you also want to think about deployments. This is the crown jewel in terms of actually using your model once you've specialized it. What we recommend here, I think that there's many options emerging, but tried and true way of deploying these models, I would say, is a Triton server. One, you get a server that is optimized for GPU hardware, which is a great plus. It comes containerized, so you can pull the images straight from Docker, for example, to then run one of these servers. It also provides more advanced control over how the model is running inference. You can do batched inference for optimal throughput. So essentially, because it's optimized for GPU hardware, they have the ability to batch all of the incoming requests and then use maximally the compute inside the GPU to then return the output for the variety of clients. So this is also something that we offer in Remyx. If you train a model with us, once you've trained a model, you have the ability to essentially use the Remyx CLI to then deploy one of these containerized Triton servers for your model already baked in. So that's a great way to start experimenting once you've trained a model. And this also is a great place not only to experiment, but then move this further into a deployment grade or a production grade deployment. We think it's a great option, for example, to set up in an A/B testing platform. And the reason for that is because you can also host multiple LoRa's. So basically, you can host multiple of these adapter variants in the same server and then switch. So you can, in A/B testing, you can switch which user gets to use which type of adapter LoRa that we created. So this is a great way to then further move this deployment that you've used in experimentation into a production grade where you can further evaluate that model with real human input on how they interact with it. All right. And I think these are all the topics that I wanted to cover today. It looks like I was able to finish a little early. I'd love to take the time to see if anyone has any questions or comments or areas where you'd like to discuss further. I think all of these topics generally are very rich, and it's changing still so much every day. It's really awesome to see. Oh, nice to hear. Thanks, Don. I think Prometheus, if I can take the mic here for a bit, it's a great resource. I think, especially if you are trying to make an evaluation system, whether for yourself or as a service, that gives you an avenue for further constraining that LLM evaluator for being really great at evaluating, healthcare related LLMs or robotics related LLMs. You could do it vertically. You could do it also by task. So constraining even the evaluator itself is also a great advantage to just making a more robust system. Sure, I can share more how mix match works. I'm happy to do that. So I can show you real quick. Let's go back to that part of the deck and see if I have. Actually, I might even be able to share with y'all how that works from the app itself. That might be more interesting even. Let's try sharing that. All right, so I'm in the Remyx AI app, and if you wanted to try this out, it's free. So feel free to hop on. All you need is either a GitHub handle or a Gmail to authenticate and be able to run your own models. But essentially, the way mix match works is that we have a list of models that we want to go ahead and compare, and we're expanding this actively. Right now, we've kind of focused it more on the smaller models since they're the most portable and generally most accessible even to just practitioners. But the idea here is that we have all of these models and we take two kinds of scores to be able to evaluate how well of a fit a model is for your example prompt. So one of those scores is if we essentially force the LLM to put on a hat of expert in the domain that you've put in as a prompt. So if I were saying, what is the foundational principles of constructivist learning theory, I'd make the LLMs put on their hat of education professional, and also put on the hat of total novice. I have no idea what you're talking about. And then understand how well the responses of the model, once it's assumed that persona, are aligned to the prompt itself. So how well is it at being an expert, and how well is it as it being a complete novice to that task? And then that's one part of the score. And then the second part of the score is just getting a baseline read. So we take that model, we produce an output, and just baseline how well does the response align to the prompt? Is it completely off? Is it giving me something that's garbage, or is it giving me something that seems like a plausible response? And maybe if we did a little bit more tuning, that it would be really close to that result. So a combination of those two scores essentially gives us the ranking from 1 to 5. How well of a fit is it? So if I go back in here, I could probably go ahead and see, for this particular example, this was my prompt. I wanted to make that startup advisor. It looked like if I look at all of these, the Gemma one was a good one. Code Llama was a good one. And I could, for me, even with my intuition, instruct variants are pretty good typically for this kind of task when you're asking a question and want a response. So that's what informs these scores here. And so if you were on the Remyx platform and you wanted to see which one works best for whatever task you're going for, you could also go ahead and train, and then it'll send you over to go ahead and train a model with. But yeah, essentially, that's how that works. Thanks, Katie. I'm glad you came. Awesome. Good to hear. We love feedback too. So anything pops up, or if you have any projects you're working on, we are all open ears. We love to hear it. And we're actively expanding what kinds of tools we could allow for folks that make them faster and just reduce the frictions to actually getting a result out and building with foundation models. All right. I'll stick around for another 5 minutes if anyone else has any questions. But thanks again for sticking with me. I think hopefully a lot of the resources here were useful to y'all. Again, if any thoughts or feedback come up after the fact, don't hesitate to reach out. We're more than happy to DM on LinkedIn or Twitter, or even hop on a chat anytime.